This is Spacetime, Series 28, Episode 61, for broadcast on the 21st of May, 2025. Coming up on Spacetime, the biggest solar flare this year, the biggest geomagnetic storm in the past 20 years, and the most extreme solar storm known to have hit the Earth. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
Well, we've just experienced the largest solar flare so far this year, producing an X2.7 class event. The massive eruption emanated from a newly appeared active sunspot region catalogued as AR14087. It's one of two X-class flares and several smaller M-class events, all coming from the same region. Now, luckily, they weren't pointed directly towards the Earth, leaving the planet on the outer edge of the strike zone. But of course that's now changed, as this active region has now rotated to directly face the Earth. The event happened as the Sun reaches solar maximum, the climax of its 11-year solar cycle. Solar flares are powerful blasts of energy erupting from sunspots on the Sun's surface. Sunspots are slightly cooler regions on the Sun's surface, the photosphere, caused by magnetic field lines from deep inside the Sun, breaking through the surface and looping out into space. Now, because the Sun is fluid rather than solid, different latitudes rotate at different rates, and this causes the magnetic field lines to twist and snap. When they reconnect, a process called magnetic reconnection, it triggers powerful explosions near the surface known as solar flares. Solar flares are classified according to their strength. The smallest ones are B-class, that's followed by C, then M, and the largest are X-class flares. It's similar to the Richter scale used for earthquakes, with each letter representing a 10-fold logarithmic increase in energy output. So, an X-class flare is 10 times as strong as an M-class flare and 100 times as strong as a C-class flare. Within each letter class, there's a finer scale from 1 to 9. C-class flares are too weak to noticeably affect the Earth, but M-class flares can cause brief radio blackouts at the poles and minor radiation storms that could endanger people in space. Although X is the last letter, these flares can have more than 10 times the power of an X1 class, so they can go much higher than an X9. The most powerful flare on record was back in 2003 during the last solar maximum. In fact, it was so powerful it overloaded the sensors measuring it. They cut out at X17, and the flare was later estimated to be about at X45. A powerful X-class flare like that can create long-lasting radiation storms, which can harm and even destroy satellites, give airline passengers flying near the poles a dose of radiation, scramble communication and navigation systems, and even overload power grids, causing widespread blackouts on the ground. The most powerful solar flares can trigger coronal mass ejections, huge blasts of the Sun's material, including protons, electrons, magnetic field, and helium nuclei. Now, our current solar cycle, number 25, began back in December 2019, and so should be reaching solar max around now. This is when the Sun reaches its most violent phase, with lots of sunspot activity and consequently lots of solar flares and coronal mass ejections. The number of sunspots are predicted to reach a peak of around 115 by July this year, making the current solar cycle weaker than average and only slightly more active than the previous solar cycle 24. During each of these roughly 11-year solar cycles, the Sun's magnetic field flips in polarity. North pole becomes south and south pole north. And this flip occurs when the solar cycle reaches solar minimum, with the next flip probably occurring around 2030. This is Spacetime. Still to come, the biggest geomagnetic storm in 20 years and the most extreme solar storm ever known to have hit the Earth. All that and more still to come on Spacetime. While spectacular, the most recent geomagnetic storm events we've seen pale into insignificance when compared to the solar storm that hit the Earth just a year ago, which has now officially been listed as the biggest in 20 years. Amazingly, that event coincided with the inaugural space weather tabletop exercise. The exercise was meant to be a training event where experts could work through real-time ramifications of a major geomagnetic storm, a global disruption to Earth's magnetic field. Now, as we mentioned earlier, geomagnetic storms can decimate satellites, overload electrical power grids, and expose astronauts to dangerous levels of radiation. So minimizing the impact of such storms requires close coordination, and so this meeting was a chance for scientists to practice. But then their simulation turned into reality. The director of NASA's Space Weather Program, Jamie Favors, says the plan was to run through a hypothetical scenario, finding where existing processes worked and where they needed improving. But then this hypothetical scenario was interrupted by the real thing. On May the 10th, 2024, the first G5 or severe geomagnetic storm in more than 2 decades hit planet Earth. The event, named the Gannon Storm, in memory of the leading space weather physicist Jennifer Gannon, didn't cause any catastrophic damages. But a year on, key insights into the Gannon Storm are helping scientists understand and prepare for future geomagnetic events. The Gannon Storm had effects both on and off our planet. On the ground, some high-voltage power lines tripped, transformers overheated, and GPS-guided tractors veered off course in the Midwest United States, further disrupting spring planting that had already been delayed by heavy rains. In the air, the threat of high radiation exposure, as well as communications and navigation losses, forced numerous transatlantic and transpacific flights to change course. During the storm, Earth's upper atmospheric layer, the thermosphere, heated to unusually high temperatures. In fact, at 160 kilometers in altitude, the temperature, which typically peaks at around 650 degrees Celsius, surpassed over 1,150 degrees. NASA's global-scale observations of the Lyman Disk, or GOLD mission, observed the atmosphere expanding from the heat generated to create a strong wind that lofted heavy nitrogen particles much higher into space. Now, in orbit, the expanded atmosphere increased drag on thousands of satellites. NASA's ISAT-2 lost altitude and wound up entering safe mode, while NASA's Colorado Inner Radiation Belt Experiment CubeSat was forced to deorbit prematurely. Other spacecraft, such as the European Space Agency's Sentinel mission, required more power to maintain their orbital altitude, and they were forced to perform maneuvers to avoid collisions with space debris. The storm also dramatically changed the structure of the Earth's ionosphere. A dense zone of the ionosphere that normally covers the equator at night dipped downwards towards the South Pole, forming a sort of checkmark shape and causing a temporary gap near the equator. The Gannon storm also rocked Earth's magnetosphere, the magnetic bubble that surrounds the planet. Data from NASA missions MMS and Thermus Artemis saw giant curling waves of particles and rolled up magnetic fields along the edge of the coronal mass ejections. And these waves were perfectly sized to periodically dump extra magnetic energy and mass into the magnetosphere upon impact, in the process creating the largest electrical current seen in the magnetosphere in 20 years. Incoming energy and particles from the Sun also created 2 new temporary belts of energetic particles within the magnetosphere. These belts form between the existing Van Allen radiation belts which permanently surround the Earth. The storm also ignited auroral activity around the globe, including at lower latitudes where these celestial light shows are rare. NASA's Aurorasaurus project was flooded with more than 6,000 observer reports from over 55 countries on all 7 continents. Photographers helped scientists better understand why the aurorae observed throughout Japan were magenta rather than the typical red in colour. Researchers studied hundreds of photos and found that the aurorae were surprisingly high, around 1,000 kilometres above the ground. That's around 320 kilometres higher than red aurorae typically appear. In a paper published in the journal Scientific Reports, the authors found the peculiar colour of the aurorae likely resulted from a mix of red and blue aurorae, produced by oxygen and nitrogen molecules lofted higher than usual as the Gannon storm heated and expanded the upper atmosphere. And impacts of the Sun's amped-up solar activity didn't end in Earth space. The solar region that sparked the Gannon storm eventually rotated away from our planet and redirected its outburst towards the planet Mars. As energetic particles from the Sun struck the Martian atmosphere, NASA's MAVEN orbiter watched the aurora engulf the red planet from May the 14th through to the 20th. And solar particles overwhelmed the star camera on NASA's Mars Odyssey orbiter, causing the camera to cut out for almost an hour. Meanwhile, down on the Martian surface, images from the navigation cameras on NASA's Curiosity rover were freckled with snow, streaks and specks caused by the charged particles. Curiosity's radiation assessment detector recorded the biggest surge of radiation since the rover landed on the red planet Mars's Gale crater back in 2012. Now, had astronauts been there, they would have received a radiation dose of around 8,100 micrograys. That's equivalent to some 30 chest X-rays. The Gannon storm spread aurorae to unusually low latitudes. In fact, it's been called the best documented geomagnetic storm in history. And the data captured during this historic event will continue to be analysed for years to come, revealing new lessons about the nature of geomagnetic storms and how best to weather them. This report from NASA TV.
In May 2024, a spectacular multicoloured light show flooded the skies across the world. These displays are known as the auroras. They're usually seen near the polar regions, but that May, skywatchers spotted the glowing lights far from Earth's poles. People were witnessing the biggest geomagnetic storm in over 20 years.
This storm was so intense. It was the most intense in 2 decades. This was one of those large events that we've been talking about for years.
It all began from this active region on the Sun. Active regions are known for having intense magnetic fields, and the more tangled those fields become, the more likely they are to erupt.
We watched the active region evolve, and we thought that this might be something to watch and might be something active.
Eventually, the active region unleashed a chain of huge solar eruptions directly towards us.
What made it so strong was the fact that there was so much energy put off by the sun. It was really great conditions for the perfect storm.
On May 10th, the eruptions reached Earth, triggering a global disruption to Earth's magnetic field, known as a geomagnetic storm. It was rated a G5, the rarest and strongest type. The powerful storm pushed auroras to appear in unusual places like Arizona in the United States and Perth in Australia.
That energy interacted with the Earth and created the aurora and caused all sorts of disturbances that we felt here on the ground.
The storm caused some high voltage lines to trip and transformers to overheat. Transatlantic flights rerouted due to risks of high radiation exposure and communication and navigation disruptions. Farther up, NASA saw Earth's upper atmosphere get unusually hot. The temperature 100 miles up in the thermosphere usually peaks at 1,200 degrees Fahrenheit, but during the storm, it reached 2,100 degrees Fahrenheit. The heating caused the atmosphere to expand, which affected satellites.
There were thousands of satellites that had to move their orbits because the storm was coming through.
The storm also affected the space beyond Earth. It created 2 new temporary belts of energetic particles around our planet, adding to Earth's 2 permanent ones, which are known as the Van Allen radiation belts. The particles in these belts can harm orbiting satellites and astronauts heading for deep space, so NASA studies them closely. As the Sun rotated, the active region eventually moved away from Earth and redirected its outbursts towards Mars. On Mars, NASA's Curiosity rover saw solar particles from the storm. The rover also recorded the biggest surge of radiation since it landed in 2012. If an astronaut had been on the Martian surface, they would have received a radiation dose equivalent to 30 chest X-rays at once. With spacecraft throughout the solar system and modern cameras in so many people's pockets, the storm was the most well-documented in history.
There's lots of data. We're able to actually use that data to understand things and predict more and more how this is going to affect our Earth.
Although the storm passed within days, NASA will continue to learn from the observations for years to come, helping us better prepare for the next big storm.
And in that report from NASA TV, we heard from NASA heliophysicist Kelly Korek. This is Space Time. Still to come, the most extreme solar storm ever known to have hit the Earth. And later in the science report, a new study claims people who work long hours could have altered brain structures. All that and more still to come on Space Time. New researchers uncovered the strongest solar event ever recorded, in the process rewriting science's understanding of space weather and radiocarbon dating. This new finding expands the timeline and intensity of known solar activity and sets a new upper boundary for such solar phenomenon. The study's authors discovered an extreme spike in radiocarbon corresponding to the year 12,350 BCE during the dusk of the last ice age. The study by Celia Goloubeko and Ilya Uzorskin from the University of Oulu in Finland utilized their newly developed chemistry climate model, which was specifically designed to reconstruct solar particle storms under ancient global climatic conditions. The model confirmed that the detected solar event was approximately 18% stronger than the notorious year 775 event, which until now had been the strongest solar storm ever recorded using tree ring archives. Goloubeko says that compared to the largest event in the modern satellite era, which is the 2005 particle storm, the ancient 12,350 BCE event was more than 500 times more intense. Other large known solar particle events occurred around the years 994, 663 BCE, 5259 BCE, and 7176 BCE, and a few other candidates are still being investigated. The new model was verified using wood samples recently found in the French Alps, dating back some 4,300 years. Solar particle storms are rare, but when they occur, they bombard the Earth with an enormous amount of high-energy particles. In comparison, the famous Carrington solar storm of 1859 was a different kind of event and not accompanied by a solar particle storm. Goloubeko says the ancient event in 12,350 BCE is the only known extreme solar particle event outside the Holocene epoch, which is the past 12,000 years of stable warm climate. With this model, the authors were able to assess the strength, timing and terrestrial effects of what is now the most powerful and extreme solar particle event ever known. Solar particle storms can greatly enhance the normal production of cosmogenic isotopes like radiocarbon-14 in the atmosphere, which are produced by galactic cosmic rays. Such enhanced production, preserved in annual tree rings, serves as a clear cosmic timestamp, making possible absolute dating of tree samples. These dramatic spikes, known as Miyake events after the Japanese researcher who first discovered them, offer invaluable data for scientists studying both solar activity, ancient Earth systems, and space climate. Miyake events allow scientists to pin down exact calendar years in floating archaeological chronologies. Radiocarbon signals from such events have already enabled researchers to precisely date Viking settlements in Newfoundland and Neolithic communities in Greece. The findings are revising science's understanding of solar physics and space weather extremes, and this event establishes a new worst-case scenario. Understanding its scale is critical for evaluating the risks posed by future solar storms to modern infrastructure, such as satellites, power grids, and communication and navigation systems. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study claims that people who work long hours could have altered brain structures. A report in the Journal of Occupational Environmental Medicine looked at brain scans of 110 participants who worked either 52 or more hours a week or a standard 35 to 40-hour week. They found that when compared with those who worked standard hours, those who worked excessive hours had changes in brain regions associated with working memory, problem solving, and emotional regulation. Now, while this study only provides a snapshot, can't be used to show cause and effect, the authors say previous research had linked overwork with various health issues, and these results can help provide more insights into overwork and our bodies. Engineers have invented a smart sponge-like device that can capture water from thin air. A report in the Journal of Cleaner Production claims the system uses the sun's energy and works even in low humidity, where other technologies such as fog harvesting and radiative cooling have struggled. They say the water from air device remained effective across a broad range of humidity levels from 30 to 90% and temperature levels between 5 and 55 degrees Celsius. A new study claims that a ban on smartphones and social media access for kids doesn't promote a healthy use of technology by children. The The findings, reported in the British Medical Journal, claims the focus should move to a rights-based approach with age-appropriate design and education, one that protects kids from harm while developing the right skills to help them participate in a digital society. The authors say that blanket restrictions on technology like smartphones are a stopgap solution that does little to support a child's longer-term healthy engagement with digital spaces across school, home, and other occasions. Australian telecommunications giant Telstra has begun testing the Starlink broadband satellite network for remote customers beyond the conventional cell phone network. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Yeah, well, they've been testing their Starlink capability to send text messages to people, and they're going to launch this in Australia later this year. Now, this mirrors what Verizon did in the US with their ability to send messages via Starlink, and this is augmented over what Apple launched a couple of years ago, or the iPhone 14, which has now been extended to the iPhone 13 to send emergency messages via SOS, and now, of course, you can send other messages and use Find My and let your relatives see where you are. But in other parts of the world, like Australia and New Zealand, and phone companies are like, wow, well, we can send messages and hopefully eventually soon also make phone calls via satellite networks when people are outside of the traditional cellular networks. And this is a very handy capability. So Telstra has sent 55,000 text messages in its testing phase. And so this is basic testing. You don't have to be doing this for emergency purposes, but it is for hard to reach places where the network doesn't exist. You know, this is part of the ability for regional Australians primarily, because they're the ones who live outside of the traditional 4G and 5G mobile network coverage. And they did also send 500 plus messages in the live trial, and they've been also sending GPS coordinates and emojis via text message. So this is an awesome update to the ability for the world to stay in contact, you know, wherever you are. And the ubiquitous communications that we've sort of, I guess, dreamed of for years, ever since we've had satellite calls via Iridium and then the mobile networks that have grown and grown. This is the next logical step. And given the fact that Elon Musk wants to get us all to Mars, no doubt at some point soon this will be interplanetary as well. But for the time being, we're still firmly anchored here on Earth.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. Spacetime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. Spacetime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Spacetime store for a range of promotional merchandising goodies, or by becoming a Spacetime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.